Everybody right now is chasing AI tools, new tool, new agent, new framework, new hype. But almost nobody is understanding the actual framework behind production grade AI agents. And that is a massive mistake. Because the people who understand this layer will build the next generation of AI systems and not just use them. Today, I'm going to show you the four fundamental building blocks quietly shaping the future of agentic AI. Agents.md, Goose, MCP, and Agentgateway. Once you understand these four pieces, suddenly every AI company starts making sense. Be it Google, Anthropic, OpenAI, Cursor, LangChain, or all of them. By the end, you'll understand how real AI agents are designed, how they connect, how they scale, and the industry where it's going. Also, what gaps still exist. At the end, I'll show you the exact AI lifecycle map companies are quietly building around these technologies. Quick clarification, this is not a beginner video on what AI agents are. If you're completely new to agents, watch my earlier video first. Today is different. Today we are going deeper. Most people talking about AI agents online are still stuck at prompting. But production AI systems need standards, runtime, protocol, governance, interoperability, security, orchestration, and operational control. This is where these four projects come in. The four pieces are Agents.md, Goose, MCP, and Agent Gateway. Now think of them as four layers of modern AI operating system. The crazy part is that different companies are quietly building variations of same architecture, be it Google, Anthropic, OpenAI, and startups, converting the same pattern. But there's one massive missing layer almost nobody is talking about yet, and that's where the biggest opportunity still exists. Let's start with Agents.md. Now, this might be one of the most underrated ideas in AI right now. Agents.md is like README file but for AI agents, or even better, a job description for an AI system. It defines what the agent can do, what tools it can access, its responsibilities, limitations, operational expectations, and instructions. This matters because most agents right now are basically YOLO systems. People throw prompts together, connect random tools and memory, and hope it works. That does not scale. Production systems need structure. Agents.md standardizes how agents' instructions work. When standards start appearing, it usually means an industry is maturing. The internet had standards, cloud had standards, containers had standards. Now AI agents are entering that phase too. But defining an agent is only step one. Next problem, how do you actually build these things without reinventing the wheel every single time? Alright, this brings us to Goose. Goose is an open source framework for building AI agents. Instead of building everything from scratch, Goose gives developers reusable building blocks and runtime abstractions. Means less glue code, less chaos, more scalable systems. Now, building production AI agents is hard. You need tool orchestration, memory handling, reasoning loops, execution flow, error recovery, context handling, permissions, logging, and governance. Most demos online ignore this reality. Goose try to make that easier. The bigger shift is that AI is moving from single prompts to software defined autonomous systems. This is a completely different engineering challenge. But even Goose has a major limitation because agents are useless if they cannot dynamically interact with the real world. That brings us to MCP, the Model Context Protocol. MCP is probably the most important concept in this entire video. It is becoming the USB-C of AI systems. Now look, this might sound cliche, but before USB-C, every device had different cables, connectors, adapters, and chaos. Just in case you need another example, consider it as Kubernetes for AI agents. Okay, back to MCP. It tries to solve that problem for AI agents. It creates a standard protocol that allows AI systems to connect to tools, APIs, database, applications, external systems, as well as the runtime context. This changes everything. Agents stop being isolated model and start becoming connected systems. This is where agents become useful, not because they can chat, but because they can act, read GitHub, update Jira, call APIs, trigger your workflows, access memory, and interact with the real environments. Now, the future winners may not just be the smartest models, they will be the best connected systems. But once you have hundreds of thousands of connected agents, you hit an entirely new problem. That brings us to Agent Gateway. This is where the conversation becomes infrastructure grade. Once agents interact with multiple tools, systems, agents, and permission layers, you need coordination. You need governance, you need routing, and security and observability. So, Agent Gateway is like an API gateway, but for AI agents. While this is the latest addition to the Agentic AI Foundation Kitty, it helps manage agent to agent communication, tool routing, authentication, policies, security boundaries, and operational control. Now, this layer becomes extremely important in enterprises because enterprises do not trust random autonomous systems making unrestricted decisions, and they should not. Governance and infrastructure are becoming the next major AI battlefield, not just model performance. Now, let me connect all four pieces together because this is where people suddenly understand how modern AI architecture actually works. Now, let's connect the dots. Individually, these projects are interesting, but together they form an emerging AI lifecycle architecture. Agents.md defines the agent, Goose helps build the agent, MCP connects the agent, and Agentgateway governs and coordinates the ecosystem communication. This is the flow: design, build, connect, and operate. Once you see this, every modern AI company starts making sense for their AI stack, be it Google Vertex AI, LangChain ecosystem, Anthropic integration, OpenAI agent. All are similar architecture patterns, not identical implementations, but a similar evolutionary direction. Now, this is why architecture matters more than chasing tools. Tools change every month. Architectural patterns last for years. Now, let's map this to Google because this is where the architecture becomes very real. Agents.md maps closely to structured orchestration patterns and internal agent manifests. Google is similar in spirit to Vertex AI agent builder and orchestration tooling. And MCP resembles dynamic integrations between Vertex AI, API, plugin, and external systems. And Agent Gateway resembles API gateways plus service mesh governance and secure coordination layer. Different naming, different implementations, same larger directions. The industry is converging towards platform thinking for AI systems. But here is the important reality check. Even with all these technologies, agentic AI is still early, very early. There are still massive unsolved problems. Testing, monitoring, trust, memory consistency, security, human approvals, observability, ethics, and alignment. List goes on. The industry is still figuring out how to safely run large scale autonomous systems. That is where the next energy going on and opportunity exists. Not just building agents, but building trustworthy agent ecosystem. So next time, let's say somebody do a flashy AI demo, look deeper, ask how is the agent defined? How is it built? How does it connect? How does it govern? Because that is where production AI begins. So if you understand these four layers, you're already ahead of most people entering the AI space right now. I'm going to link GitHub repositories, projects, learning resources in the description. And if you want the next video, I can break down Google's Vertex ecosystem, how it maps the architecture, how enterprise AI systems are evolving, where AI infrastructure is heading next, and why AI governance may become bigger than AI models themselves. For that, you need to subscribe if you want fewer AI gimmicks and more real world AI architecture thinking. See you in the next one.